Hey everyone, welcome back to Passlite Academy. Today we are having physics. If you are preparing for any exams like WAEC, JAMB, or you are an SS2 student, please, you need this topic. Rectilinear propagations of light. So under that, we also talk about the definition of light. What is light? A light is a luminous object. That is the energy that causes the sensations of visions which enable us to see the natural source of light, and we have the artificial. Well, anytime you say natural, that is made by what? God. Then you say natural, artificial. Now this one is made by what? Man-made. So example of natural, you can have your sun, your star. They are natural. They're man-made, yeah, like your torchlight is man-made, but they produce light. Your candle, they produce light, etc. So this is artificial. Also, let's go to difference between luminous and non-luminous objects. Luminous and non-luminous objects, let me just draw it. Then the self-luminous of living creature. This one is object, but living, that is living. We have the glowworm. They also produce light at night. So we also have the third one, which is the non-self-luminous. This one is man-made art. Example, we have the electric, candle, torchlight. So what do you understand by the word luminous and non-luminous? Luminous is anything that produces light by themselves. This one produce light by themselves, while this one did not produce light by themselves. That is the difference between luminous and non-luminous objects. This one is transmissions of light. That is the fourth one that we have here. So when you have the transmission of light, now what is transmission of light? When a light or rays of light fall on an object, we have a rays of light on an object this way. So some part is transmitted and some part is reflected. So that is what we call transmissions of light. So there are three things that I want to talk about transmission. The first, we want to talk about the transparent object. Then we want to talk about the translucent objects. And lastly, we want to talk about the opaque object. So let's explain this one by one. What is a transparent object? When large, don't forget what I said transmission means. Some parts will be reflected and some parts will be transmitted. But when you have a large amount of light that is transmitted and little is reflected, then we said it's a transparent object. The example of this one, when I talk about this one, you're talking about glass. A transparent object is that you can see through them and light can pass through them. So when you have a glass, you can see the other side of the glass and light can also pass through. So that is a transparent object. I also have water too, etc. So all these, they are transparent objects. So let's go to translucent. This type of object here is when little, inverse of this one now. When little can be transmitted, then large can be reflected. This one, light can pass through them, but you cannot see the other side of them. Example like tissue paper. Example of this, we have tissue paper. We have frosted glass. Example of this frosted, like your colored glass or tinted glass, like your mirror, that they will tint the back of the mirror. So mirror is an example of a translucent object, meaning that little can only be transmitted, but large can be reflected. So let's go to opaque objects. This one, both of them are little. So little can be transmitted and little can be reflected. Example of this opaque object now is this one, light cannot pass through it and you cannot see through them. Again, this one, light can pass through and you can see through them. This one here now, light can pass through, but you cannot see through them to the other side. Why this? Light cannot pass through and you cannot see through them. That is an opaque object. Example, wood. Wood is an opaque object. You cannot see through wood and light cannot pass through. Your wall is an opaque object. You cannot see through wall and light cannot pass through. So that is the difference between transparent, translucent, and opaque objects. Now the fifth one is propagation of light. That is it on the propagation of light. We want to talk about the light and sound. Now light has vision. That is the first one. It has vision, you can see through them. But sound did not have vision. Not vision. Light has a shorter wavelength. So this one is longer. 3. Light has higher frequency. While sound is lower frequency. The fourth one, light has what? The greater speed. Please know this if you are writing WAEC or any exams that is pertaining physics. Because they used to ask all this in your objective. So greater speed, while this one is lower speed. Also, light is a transverse wave, while this one is a longitudinal wave. So this thing has given the clarity between light and sound. under the propagations of light. Now, the sixth one is rays and beam. A rays is just a path or direction. It's a path or directions. So that is what we call rays. Then when you have beam, beam is the connections of rays. Beam now is a collection of rays. That means when you have two or more rays, we call it beam. So, and there are different types of beam that we have. Types. We have parallel, we have convergent, and we have divergent. As the name implies, parallel, all rays move in parallel from this way. All rays move in parallel. So we can say this is parallel. But when you say converge, all of them, they meet at a point. So all of them come this way at a point this way. So this is just a typical example at a point this way. So that is what we call converge. When you have a diverge, they spread out. When they spread out, spread out, spread out. So this is diverge. Diverge means that they spread out. Converge, all of them, they come back to a source. When we have parallel, all of them move in a parallel form. So these are the three types of beams that we have. Rectilinear propagation of light. Rectilinear propagation, as name implies, I said rectilinear. Rectilinear means straight line. So when a light moves on a straight line, that is what we call rectilinear propagations of light. So there are a phenomenon in which there are three phenomena here that work on the propagations of rectilinear of light. The first one, we have the shadow. Second, we have the eclipse. And last one, we have the pinhole, which is pinhole camera. So under shadow, we have what we call umbra and penumbra. Umbra means total darkness. You know, have the same shadow that you know. That if you are going on the road in the night, you see your shadow at the other side. Like the way if you see the board where you see my shadow on the board, so that is what we call shadow. So we have some that is umbra. Umbra means total, the total darkness. While we have the penumbra. Penumbra is partial darkness. So these are the two that we have here. Then let's go to our eclipse. There are three eclipses. We have the solar, which is SME, the sun, the moon, and the earth. And we have the lunar, which is SEM, the sun, the earth, and the moon. So we have the alunar. Alunar is the moon, the earth, and the sun. And lastly, we have pinhole. So the last things to work on today is our pinhole camera. That is the last one I work on. So what's our pinhole? Pinhole is just like constructed. They have a screen, like the mirror, and as what we have seat. So for seeing the objects. So on these magnifications of on a pinhole camera, what are these magnifications? That this, because pinhole camera and this camera is something that produce image. So here we have M means magnifications is ID over OD. What is your ID? V. What is your OD? U. Then what is another one? M is equal to V over HO. So these are the formula that we use on magnification. What is ID? ID means image distance. Image distance. Then we have OD, object distance. Then we have HI. HI now, height of the image. Then we have HO, height of the object. So that is what we have in. Why M means magnifications. Look at the questions. Learn how to read and interpret the question. It's always very, very important. So this is UTME question 2012. So we have this way. A pinhole camera. Pinhole camera is the object. It's placed 300 meters in front of a building. So the distance of this, you can see that they place 300 meters. So that is the object distance, OD. Or you can use as U. U means object distance. Is 300 meters in front of a building, so that the image now is formed on a screen. So the image of this pinhole now, so that is ID, image distance, which is V. This image, V, 5 centimeters. This one is the meter, this one is centimeter. Convert, make sure all of them is the same units. And our answer is the meter. So let's convert this to meter too. Divide by 100. From center, so divide by 100. What do you have there? So it's 0.05 meter. So continue from the pinhole camera. If the image is 2.5 centimeter, so if the image is 2.5 centimeter height of the image, I is 2.5 centimeter. Divide by 100 too as well. So you have 0.025 meters. So let's see. The height of the building would be the height of the building's objects now. The height of the object. Now, the height of the building, we don't know the height of the objects. We don't know that. So let's look at now. Recall. Our formula for magnification is M is equal to V over U. And at the same time, M is equal to height of the object over height of the image over height of the object. So you can join this together. V over U is equal to height of the image over height of the object. So what is your V on the board? 0.05. What is your U on the board? 300. What is the height of the image on the board? 0.025. Over what is the height of the object? HO, we don't know. S. So cross multiply this times this, what do you have? This means this, so you're having 0.05 S is equals to, this means this 300 times 0.025. Let's use calculator. 7.5. Divide both sides by 0.05, the other side by 0.05. So this cancel this, S equals to this divided by this is 150 meter. So that is, just check the option, that is option D. Now try this and put it on the comment sections. A man 1.5 meter tall is standing 3 meter in front of a Pinot camera, whose distance between the hole and the screen is 0.1 meter. What is the height of the image of the man on the screen? So you have the option 0.30, 1.00, 0.05, 0.15. UTME 2013. And please don't forget to like our videos, subscribe and share to those people that actually need the videos. And please try to comment, so when you see your comments, you know what you are doing right and what you are not doing right.